Hey guys, I wanted to do a little review of this PowerPoint that I posted. I have a PowerPoint that has reviews and FRQs for every topic, and I'm just going to roll them out like slowly. Little heads up, College Board is releasing kind of like a statement and dates on Friday that will tell us more about what is going to be exactly the format of this exam. We know right now it's going to be 45 minutes and three FRQs. Which is not ideal because most of our tests have been multiple choice, and you guys have rocked them. But that'll only help you guys make sure that you know the concepts and stuff, even if you want to continue practicing multiple choice questions. I've also heard rumors and seen tweets that it's actually open note, which of course it kind of has to be since it's going to be administered from home. So I guess they're just kind of being like, well, we know people are going to have their notes, so we'll go ahead and call it open note. But that being said, they're going to have questions that, first of all, you wouldn't have time in 45 minutes to both look at your notes and answer the question. Or also, it's not as much as about whether you have notes and information, it's can you apply the information. So that's when I had this practice FRQ that's due this Friday for you guys. I want you to do your best, and then I want you to check the rubric, which to me would be essentially like checking your notes and improve your answer in any way you can, because that'll be a similar experience to what you guys are going to have. Um, this is obviously unprecedented for College Board to have some kind of format like this, and it's okay. We're all just kind of fumbling around blind, trying to figure out how the best way to give you guys credit for this year that you guys have put in a lot of effort. I think you already know that we're not going to do evolution and we're not going to do ecology. So that's kind of nice, but at the same time, it's kind of sad that we're going to miss out on two of the more interesting practical units that tie the whole course together. But it is what it is. So if you guys take this class in college again, you won't have the background of evolution and ecology, but you'll have the background of everything else. And I think that hopefully you'll pass and won't need to take the class. And if you don't, then hopefully you'll have a really good foundation uh, in these biological concepts. So experimental design review um, seems so simple and basic, but remember, like, this is always question one on the FRQs. I assume that's probably still going to be the case. And what better way of seeing if people can apply their knowledge than an experimental design question? That being said, they're not probably going to have you do a bar graph online, but they probably have you interpreting standard error bars, looking at your own graph that's been given to you, and then having you guys interpret the data, identify the variables, identify a positive control or a negative control or whatever that would be. So make sure that you go through this and remind yourself how to interpret error bars, what do error bars represent, what are they asking you to even do in the prompt? How can you identify that you're actually answering the question and not just talking a lot about stuff they don't care about, especially in that condensed 45 minutes. And 45 minutes is just like a class period for us. So you have to think like, okay, that's three FRQs in a class period. Like we got to go. So I'm going to go through this PowerPoint with you guys, hopefully help remind you of things and show you guys the answers to some of these FRQs that I embedded throughout. Okay, first thing, it talks about these task verbs. This is in the CED, which is the course exam description on page 199. Also, I posted a little graphic under the module. It looks like this. And it just has all the task verbs. You guys, if I were you, I would print this and put it in a binder just to have as a reference when you're taking the exam to make sure that you're properly answering the prompt and that you are addressing exactly what they want you to. Because if they say calculate, they want a number. If they say construct, they want you to make a graph, or they want you to make some kind of table or something. So just make sure that you are actually doing what they're asking. There's like a corny little thing, ATP in biology, answer the prompt. So just make sure you're answering the prompt and not just wasting your time. Remembering our basic science concepts of what a null hypothesis is. We did these in the beginning of the year. That says that basically the independent variable will have no influence on the dependent variable. So if you wanted to pull out notes on this, this would be like our sketch notes with like the goldfish. In the beginning, we looked at a null hypothesis and the independent variable and the dependent variable. But let's say we're looking at an experiment. How does rain affect plant growth? Then your null hypothesis would be amount of rain has no impact on plant growth. An alternative hypothesis is probably more what you're used to doing in general bio, that you make your own prediction. So if there's more rain, then there will be more plant growth. So that's where you actually come up with something that you're making an educated prediction about. You're not just saying rain has no effect or fertilizer has no effect or whatever the case may be. You're not just being like, no. You're actually coming up with some kind of, well, this is my theory kind of, and we can test this specifically. Independent variable is what the experimenter is changing or manipulating, or in the experiment with how does the amount of rain affect plant growth, then your independent variable would be the amount of rain. Your dependent variable is what you actually go measure after you set up your experiment. So what are you going to go measure is you're going to go measure the plant growth. You're going to go see and observe or measure it. So yeah, not just measuring, but also observing it. So that, what are they even looking for? They're looking for how much the plant's growing. So that's your dependent variable. The difference between, you like, I just coughed on my baby. I'm a great mom. The difference between a controlled variable and a controlled group. A controlled variable, sometimes I call those constants. Controlled variable is going to be something that remains the same between every group that you're doing. So how does rainwater affect plant growth? Same type of plant, same yard that they're in. Like, you know, they need to be exposed to the same amount of sunlight. All those different things. Same. So you'll have lots of controlled variables. You'll have, again, I call them constants sometimes. They remain constant between all the different groups. And it's going to, you know, whatever's the, you know, like I said, the same amount of light, the same amount of soil, the same amount of fertilizer. Everything's the same except your independent variable, which is what you're changing. And in this case, you're changing the amount of rainwater that they're getting. The control group is one that does not get the independent variable. So I would have to have a plot of, you know, plants, or like a little section of plants that have the same type of soil, they have the same amount of light, they're the same type of plant, but they do not receive our independent variable, which is rainwater. So I would make sure somehow that they did not receive rainwater, and so that I could say, okay, this one that got no water is dead. And these ones that got different amounts of rainwater show different amounts of growth. So I know that my independent variable did have an impact on my dependent variable. So I could reject my null hypothesis and say rainwater does impact my dependent variable. So my control group is one that does not receive the independent variable. And sometimes they'll call that a negative control. All right. I've been kind of talking about this, but I've been talking about rainwater instead of fertilizer. So how does, might need to take a little pause here. Okay. So design an experiment to test the effect of fertilizer on plant growth. It should say plant growth. So I'm not going to go through a ton of this because I've kind of been talking about it, but basically you could have two different plants, a control group and an experimental group. One receives fertilizer, one does not receive fertilizer. The one that doesn't get fertilizer is your control group. They need the same amount of light, the same amount of soil. They need to be the same type of plant. Those would be your controlled variables. And then just, you know, observe them after a week, and your independent variable would be whether or not they got fertilizer, and your dependent variable would be the amount of plant growth. You can make the experiment much more elaborate with much more plants and everything else, but remember, you're writing it out. I would just try to make it as simple as possible. One with, one without. These things are the same. After a week, I measure it, blah, blah, blah. So it doesn't have to be too deep. Whenever they say design an experiment, I always get like nervous. Like, wait, what do they want me to do? Do they want me to like talk about exact species of plants that I'm using? Like, I get really stressed out, and then I'd realize like, oh no, it's like super like broad, and you can just be like, take a plant, add fertilizer, take another one, don't. Make sure they're the same species of plant, but you don't have to specify which type of species. So just kind of broad, general. Make sure you go through independent variable, dependent variable, constant, control group, experimental group. Okay, this is from the 2013 exam. In an experiment, rats averaging 300 grams of body mass were tested several times over a 3-month period. For each individual rat, urine was collected over a 3-hour period after ingestion of 10 milliliters of water, alcohol 1% or 5% alcohol. The volume of urine was then measured, and the results were averaged for all the individuals within each experimental group. The data was shown. So when I'm looking at this before I even look at the questions, I'm thinking, okay, the independent variable is the amount of alcohol. So it's 1% alcohol or 5% alcohol. Our control group is one that received no alcohol. So they received water. So my group that received water is my control group. The amount of alcohol or the percentage of alcohol is my independent variable. And my dependent variable is my average urine output. So I could go ahead and label those if I wanted to and say, okay, this is my dependent variable, this is my independent variable, and this is my control. Okay, and then that means the other two groups are both experimental groups. Pose one scientific question that the researchers were most likely investigating with the experiment. So we're seeing that they're looking at different concentrations of alcohol and they're measuring output. So a scientific question could be, how does alcohol affect urine output? So it doesn't have to be that deep. They're just, how does the independent variable affect the dependent variable? So how does the amount of alcohol consumed affect the average urine output? And then I'm going to kind of look at the data. I'm going to say, okay, well, water, the average urine output was 3.5. With some alcohol, we had more urine output at 3.8. And with more alcohol, I had even more urine output. So I'm thinking, just interpreting the data, it looks like drinking more alcohol is going to increase urine output. Let's see what the next question asks. State a hypothesis that could be tested to address the question you posed in part 1. So remember, hypothesis doesn't have to be right. You're just going to test it. So you could say increasing alcohol content is going to increase urine output. That could be a hypothesis. Sometimes we like to say them as like if then. So if you increase alcohol content, then you will see more urine output. Or hold. Okay. Or you could say like decreasing alcohol will increase urine output. So you're just guessing. And so I look at this and I already see the trend. And so I'm just going to cheat and assume that the trend is going to be if you increase the alcohol, then you increase the urine content. But you could have a hypothesis be anything, just as long as it's reasonable. You don't want to be like, if you increase alcohol content, then you improve circulation. You're like, wait, what? Like, we're not talking about that. Using the data in the table below, in the table, describe the effect of alcohol on urine production. So we already said that. As you increase the concentration of alcohol, then you're seeing an increased output of urine. That's it. So that's not too bad. Didn't need to know any content from that. You really wouldn't need to check your notes. All you would need to do is know how to interpret an experiment and identify the variables. So I would expect you're definitely going to have one, something like that. Okay. Next. Wait. Whoa. How do I get this thing to go down? Sorry. It's just like a real lecture with me. There's this awkward time where technology is confusing me. Okay, let's see if I can move this. And down. Okay. Confidence intervals and error bars. Oh, fun. So if you're in statistics, you have a benefit of knowing how to interpret these things. But remember, the bigger the error bar, the less reliable the data. And then if there is an area where the values would overlap, again, you can think of it as like shading all the way across where these bars are. And if there's any overlap where you would shade, that means that there's no significant difference between the means of the data. So we cannot say that there is a difference between the two sets of data. We usually use a 95% confidence interval. Remember, that's 2 standard errors. Standard error is just taking into account the sample size, where standard deviation does not. Remember, a good sample size is 30 or more. So if they ask you to design an experiment with a reliable sample size, you just want something more than 30. Okay. Looking here, this is an experiment where they're trying to see if the release of prolactin into the blood is going to be affected by exercise. And we can look here. So this is our levels of prolactin in the blood with exercise and without exercise. The time they measured it without exercise is our control group. And this is at the beginning of exercise, and this is at the end of exercise. So 0 hours and 1 hour, and this is at 0 hours and then just an hour later. And so looking here, I see all of these bars are overlapping. So there's no significant difference between the amount of blood prolactin levels before or after exercise, or either with or without exercise. So right off the bat, I know there's no significant difference of really anything. Justify the use of without exercise as a control group. So if they're trying to see if exercise is affecting it, then you would want a control group where you have not used the independent variable, which is exercise. So a group without exercise would be a control group. Using evidence from the specific treatment to determine whether prolactin release changes after exercise. Justify your answers. So after exercise, the prolactin level overlaps with it before exercise. And so there's no significant difference between the mean of the prolactin before or after. So when they say using evidence from the specific treatments, you'd say because the error bars are overlapping, there is no significant difference in the amount of prolactin in the blood before and after exercise. So I would say there is no change after exercise. And then your answer would be justified by the fact that the standard error bars are overlapping. And if you wanted to be more specific, you could even throw in numbers and by interpreting the graph, but that's probably not necessary. Okay, so if you guys remember, we did this whole thing. We did like a Bozeman guide to knowing when to use different graphs. Line graph is change over time. Bar graph is comparing, which is almost always what we use. Pie graph is parts of a whole, and a scatter plot is looking for a correlation between your independent and your dependent variables. So you're looking for trends, like positive trend or negative trend. All right, so we did this one in class. You guys can hopefully look back in your notes at that one, or the answer key, I believe, was 2017, FRQ number 1. And we looked at how does caffeine affect memory in bees at 10 minutes versus 24 hours. And you could do that here. I believe we've also done this one together, and you can Google this one. It will be available online as well if you want to look up the answers. Yeah, so that's everything. There are other FRQs that I'm going to assign you guys to do. Again, those FRQ scoring guidelines are available for you to look up. I would just like you to try and do it without looking at anything. Even if you have like 2-word answers, I just want to see like, what do you know? Go look at the scoring guidelines, improve your answer using the information that you gathered there, but putting it in your own words. And then I'll grade the whole thing together. And so what I'm looking for is to see in one color your original answer, in another color your improved answer after looking at the scoring guidelines. And then I'll grade the whole thing as if your whole answer takes into account all the pen that you have. I just want to see that you are improving and that you are showing what you already know and trying to improve and make it better. So that is everything, and I hope you guys are doing well, and I miss you. And yeah, I will see you guys for the next video, which will be on macromolecules and water. And we'll look at some I think I only have one FRQ that deals with that, but we'll look at what we have, and hopefully it will help. Well, bye guys.